Well, hello again everybody. Well, can anybody guess what this is? Go on, have a guess. Any ideas? Well, for those of you who said that it's some kind of a gramophone, because it has got that kind of look to it, doesn't it? One of those 1960s gramophones. Well, I'm sorry, you're wrong. For those of you that actually guessed that this was a valve tester, well, you would be correct. So what we've got here is my Hickok Model 533 Dynamic Mutual Conductance Tube Tester. Well, I certainly wasn't planning on making a video on tube testers today, but it just so happened that I did actually have to test a tube, and for whatever reason this tube tester wouldn't actually work properly. Now, back in the day when I first started getting into valve radios, I actually had a burning desire to own a valve tester, and this is the one that I first bought, and that was maybe, I don't know, maybe 10 or maybe 15 years ago. Now, amazingly enough, in that 10 or 15 years since I actually acquired this valve tester, I think I've used it about once, and that was probably 10 years ago. Because although I thought a valve tester was actually a very useful thing to have, turns out it's not particularly useful. In fact, the easiest thing to do if you suspect a duff valve is just to change it out for another one. And actually, even a radio receiver itself will give you a very good idea whether or not a tube is performing. I did actually get this valve tester out to test a valve, and unfortunately I wasn't able to set the valve tester up. Well, rather than giving you a really long-winded explanation, I think the easiest thing to do is actually just have a go at setting this valve tester up and see if we can find out what the problem is with it. Now, although my memory's fading a little bit, I seem to think that I actually did buy this tube tester all the way from America, and I actually had it shipped over here because valve testers tend to go for a lot more money here in the UK than they do in America. So I did actually buy it in America, and it was actually far cheaper, even with the shipping, to actually buy it from America than it was in the UK. And I did use it a couple of times, and from my best memory it did work then, but it has been in storage for more than 10 years now, and I came to use it and it just didn't work. Now, I'm sure most of you will probably be familiar with the basic operation of these tube testers. So what you have here is you've got a number of different sockets here, and they fit different styles of valves here. So I've just got a valve that I found at random kicking about on the floor. So what you would do is you would actually you would plug this valve into, I think it's that socket in this case, and then you have a book, and you need to look up the number on the side of the valve here, which in this case is an EL821. So you would get your data book out and you would look up EL821, and then based on the data book for the valve tester, it would tell you what electrodes you need to connect up, because obviously from one valve to another, one type of valve to another, the filaments or the anode or the grid or the screen grid, they all connect to different pins. So an important part of setting up a valve tester is you have to connect the right wires to the right pins on the valve before you test it. So you have these selector switches which allow you to do that. But as I say, normally you would have to look up all these various switch selectors in a data book. Now, one of the things that this valve tester has, which is quite a nice feature, it's actually got quite a lot of the common valve information in here. Can you see that? We've got like this rotating scale here which actually tells you how to set up the valve tester. So you can see on this side of the scale it gives you a list of valve numbers, and there's maybe one that I semi-recognise as 6AQ6. So if you look up 6AQ6 here, you can actually see it tells you the filament voltage is 6.3, and then it tells you the settings here for all these various switches, and then at this end of the scale it gives you some values for what things are, like the mutual conductance level, and it even tells you what part of the valve you're testing. But you can see it's a moving scale, and with all different types of valves on it. Now, of course, because this is an American valve tester, most of this scale on here, most of the data is related to American valves. So it doesn't have a lot of the valves which I'm particularly familiar with. Okay, so I'm just thumbing through the data book which has got our English valves in it, and I'm looking for EL821 because that's the valve we're going to test. So it's telling me here on the chart that the filament voltage is 6.3. So we've got to select 6.3 for our filament volts, which is actually the switch over here. So let me, there we go, 6.3. So then it gives you this long code number, which in this case is EV 2783-9. So let's set that on these switches. So that's EV 27 8 3. And then the final setting here is 9, which is the suppressor grid. So switch that to 9. So let's just double check that. Always got to double check these things because you could damage the valve. So EV 2783-9, EV 2783-9. Okay, so we're okay on that. Then we've got to adjust the bias here, which is bias we've got to set to 0. Where's the bias gone? The switch that says bias, there we go. Bias, we need to set that to 0. It's got to have this English setting here, which is 90. Oops, actually 92, something like that. And we press P4 to test the valve. And I think that gives us our GM, our mutual conductance reading. Okay, but we're not quite there with the setup, because the first thing that you've got to do with one of these valve testers, you've actually got to set up something they call the line adjustment, and that's where this process is actually failing. Before you even test the valve, you've got to set this precisely to your incoming mains voltage, and this is where I'm getting the problem. So let me plug the valve tester in. Now again, for those of you playing along at home, it's probably worth me pointing out that when I actually bought this valve tester from America, it was working on 120 volts. It's not a 230 volt machine. So what I actually had to do is I had to buy a transformer. From memory, I bought something like a 230 to 110 step down transformer, and that's actually installed in here. As you can see, it's quite a big box this, and there's quite a bit of room spare inside, so I do remember installing a transformer back then. So for those of you who are thinking of buying one of these and plugging it straight into the mains here in Britain, 230 volts, don't do that because you'll blow it up. So just looking at the valve here, I can see that the filament is just about glowing. And what we've got to do, we've got to set this line adjust. So again, I'm going off memory here because I haven't used this for a long time. We've got to press this button, and I believe what should happen when we press this line adjust button, the actual needle should rise up, and there's a portion of the meter here where it says line test. So I think that the needle should go to this line test position, and unfortunately the needle isn't even budging. Now the first thing I thought is possibly there's something wrong with this meter, because you know, these meters tend to be a real weak point on valve testers. They're very, very easily damaged. But I think when I was looking at it the other day, I did prove that, okay, if you press some of these buttons, you do actually get the meter to move. So I don't actually think there's anything wrong with the meter itself. Some of these switches are feeling, you know, just a little bit sticky, as though maybe they're not working properly. So it could be that the reason that our line adjustment isn't working is because these switches are sticking. I should be able to press this line adjust push button here, and then what we do is we actually turn this potentiometer here, and it actually adjusts the line voltage till the pointer here should go to the middle, and for whatever reason, you know, that's just not happening. So this is the line adjustment potentiometer, and I can tell that the line adjustment potentiometer is working correctly because there's a pilot lamp on here, and I can see the pilot lamp getting brighter and dimmer. So with the line adjustment turned right down, you can see the light looks quite dim. If I turn it up, it gets quite bright. I'm going to turn it back down again. But for whatever reason, when I press the line adjust, unfortunately the meter just doesn't respond at all. So I'm pressing it now, and you can see the meter isn't moving. I'm just going to press one of the other buttons at random. Okay, that one, which is, I don't even know what that does actually, P2 button. Pressing the P2 button, and you can see that it does actually go up and down, so the meter movement is okay, but yeah, there's something wrong. Now, as I've said before, it is actually quite easy to actually damage valve testers, especially it's possible to damage the meter, so you shouldn't really ever just randomly push buttons like this because you could end up damaging the meter. Well, it's been so long since I've opened this thing, I'd actually forgotten quite how many screws it's got in it. It's got absolutely loads of them. So I'll probably come back about 10 minutes later. Quite long screws as well, for that matter. Now, as I said earlier, this valve tester hasn't been used for a long time. It's just been in storage, so in theory there shouldn't be very much wrong with it. I'm hoping it's just a loose connection somewhere, or maybe a dirty switch. In theory we can just gently lift this out of here if I can get hold of it without damaging anything. Maybe a little screwdriver under an edge. I'm just looking at the unnecessarily large transformer that I put in here, and it is an unnecessarily large transformer, but I know that the reason I would have put such a large transformer in is simply because that's what I would have probably managed to find somewhere at work. So it's got a transformer in it about 10 times bigger than it needs to be. So can we see anything particularly obviously wrong? Well, we can see it's got some horrible waxy capacitors, which certainly it looks as though I didn't bother to change out in the past. This one could have a hot spot on it. I can see some wax. I've got to admit though, I did suspect though a more obvious fault than that. You know, just something like the fact that a valve or something had shaken loose in it, because as I said, the only thing that this has been done to it, if you like, it's just been in storage. It just hasn't been used for a number of years. So I'm not really expecting there to be very much wrong with it. Now, when it comes to transformers, I suspect that none of you have seen a transformer quite as complicated as this one, have you? You just look at the amount of tappings on this and, well, it's just a monster, isn't it? It's frightening to behold. I think maybe one of the first things I'm going to do is actually just take off these paper rolls, because I can see that these are the type of things that are they're just going to get damaged, aren't they? Because if I spray switch cleaner onto here, it's going to soak into the paper. So let's go away and take that off. Okay, so this is the main switch bank that switches things, and I can actually see that these switches have got grease on them. These shafts are greased with, I'm guessing it might have been white lithium grease or something like that. Maybe even I greased them last time I used it. And it just feels like, well, particularly that switch there, you can see you press it up and it kind of doesn't want to return. It's very, very lazy. So I don't know if this has had a knock at some point. Most of them spring back perfectly well, but yeah, that one definitely isn't returning back. I was just wondering if that could be our problem. Maybe one of the switches isn't returning. Yeah, that one's lazy as well. Sometimes it returns, sometimes it doesn't. At first I thought that these switches might be interlocked, so you can only press one in at a time, but I don't think that's the case. Okay, what we're going to do is let's try giving these switches a little bit of a clean. What I'm going to do is I'm going to use a bit of WD-40 because it's fine for cleaning stuff. And I do think that maybe these have got some lithium grease on, so I'm going to wipe the old grease off. We'll give them a clean with some WD-40 as a solvent, and then when we've done that, what we'll do is we'll try putting a little bit of lithium grease back on. I think that would probably work quite well. Now, of course, I don't know that this switch bank is the problem, but you know, it would be silly not to do the obvious things first, and you know, this is quite an obvious place we can get failures, isn't it? Bad switch contacts. So let's give these all a bit of a clean. I can see that switch contact as well. Maybe I'm imagining it, but it does look a bit dirty. So, oh, that one's not returning either. Let's give that a good clean. Okay, so that's a little bit better. Now I'm going to give the contacts themselves a clean with, I'm going to say, a little bit of deoxit. What I actually mean is I'm going to flood the whole area with deoxit, because you don't have any choice these days with these deoxit cans, do you? I'm afraid it is all or nothing now, because they want you to use as much of this deoxit as possible. Can I try and get it into where we want it to? Of course, that just goes absolutely everywhere. Well, it's actually quite embarrassing the amount of deoxit spray I put on that switch bank, but these new cans, it's just impossible to control. I'm sure that's the idea, they just want you to waste as much of the chemical as possible and buy more, which I guess is really quite clever marketing. I'm sure you don't need anywhere near as much switch cleaner has gone on here. This is actually just a silly amount. Well, I've just gone ahead and I've given all of these switches, I've just put a little tiny spot of lithium grease onto all these sliding metal parts, and before they were quite sticky, these switches, and they did have a habit of getting caught up. Well, I think these seem to be operating correctly now, so I'm happy about that. That's a lot better. Now, I also did feel that there's another switch on here which is to do with changing the direction of the meter from forward to reverse. When I was flicking that earlier, it felt pretty solid, it felt very dry. Let's try and see if I can get a bit of something in there. Yeah, let's not put a bit in, let's put a gallon. Well, no improvement, but maybe that's not a surprise. Now, I've got to admit, valve testers aren't actually a piece of equipment I like to work on. It's another piece of equipment that I've had fairly terrible success rates at. I've had a couple of in the past, and usually I've had problems with things like transformers, and they haven't been repairable. But one of the problems with valve testers is the circuit diagrams for them are absolutely awful. What they tend to do is they look like rat's nests of wires and cables. All the ones I've ever seen, all the manuals I've had, have been really badly faded or photocopied 1,000 times. And the people who publish them, they give you very limited information. They very rarely give you voltages or test marks or anything like that. I think this has got a circuit diagram in it, I believe. In fact, yes, there is the circuit diagram, and as you can see, they really couldn't have got much more on here. So usually I think about the only way to go through this is actually to find the push buttons, and I also noticed that none of these push buttons are actually labelled on the diagram properly, I don't think. So you've got to actually go ahead, try to work out what push button does which, and then what we'll do, I'll probably highlight in yellow marker. I'm going to highlight it on this diagram, and I think we're going to try to trace it through. But it does give you a circuit diagram, and in fairness it does give you the resistor values, so we can do the typical things like we can go and get an ohm meter and we can test every one of these resistor values, work our way painfully through all this list of components, and maybe we'll find the dodgy one. So just taking a closer look at our transformer, you can actually see the absolute tangle of spaghetti wiring that comes off these things. It's totally terrifying, isn't it? And it all goes to these, again, wafer switches, which are stacked one on top of the other. When these things go wrong, they can be very, very difficult to diagnose. And of course you can also see these multi-position selector switches, which again select things like grid bias and various other test functions. And looking at these, this one is 1, 2, 3, 4. This one is actually 4 wafers high, and actually some of them are actually higher than that and bigger than that. These things are scary. Well, I brought you back some considerable time later, and I need to start off with an apology because unfortunately I managed to lose some of the video footage in the edit. Well, that's also a slight lie. What I actually did was forgot to switch the camera on. So unfortunately you did actually miss probably the most important part of the video, which is the diagnosis, or should I say failure of diagnosis, and what I did to repair it. But we'll come back to that later. So quite often what I do when I'm faced with a problem like this is, of course, we take a photocopy of the circuit diagram and we enlarge it. And then, as you can see, I've actually highlighted some of the circuit pathways. And I've got to admit, because I really don't fully understand the way that this works, and because there's just so many of these switches, it was actually very difficult to work out how the actual line test actually gets to the meter here. Certainly all I can say is I was struggling anyway. I mean, certainly I could see that one of the contacts from our line test push button in green here, that did come down and went straight to the meter, but the other purple connection here kind of gets lost in a maze of transformer windings and rectifier valves, and seems to go over here somewhere and somehow comes back via this switch box to come onto the other side of the meter. So all I can say is I did try my best to try to fault find and diagnose it, and I didn't get anywhere. So I resorted back to, well, always look for the most obvious culprits. And what I actually found was we had a capacitor here, which I think it's, I'm not even sure where it is on this circuit. Let me see if I can find it. I think it might have been this one here, C3. So the C3 is on this purple line that I've highlighted. So I just thought, well, I was just checking all the capacitors, because we know that capacitors go bad. We just know it. So if you're not sure what the fault is, of course you fall back on the usual culprits. And when I was actually looking at this capacitor, I could see that it was actually covered in wax. But there was a spot on the capacitor that wasn't covered in wax, and there was actually some wax a little bit of wax in the bottom of the valve tester. And I've said to you before, sometimes it's a little bit like being a forensic scientist. You're not just finding information out using voltmeters and ohm meters and oscilloscope. You've got to use your eyes and sometimes backtrack. So there was a little bit of wax on the bottom of the valve tester machine in the cabinet, and some wax on the wiring. And when I took a close look at this capacitor, I can actually see that there's some wax missing from it. And if I take a real close up of the capacitor, I can see there's a burn mark on it. So I'm hoping you'll see this on camera. You can actually see there's a black mark, and the cardboard, the case of the capacitor, it's actually charred here, only slightly, but there is a burn mark on it. And of course, because the wax has run down from this spot, it's a pretty good idea that this capacitor, it's been getting red hot for some reason. Of course, capacitors shouldn't get red hot. This is clearly a fault. So actually, having spotted that, I thought, well, that's an obvious thing. There's something wrong with this capacitor either way. What I will do is I'll go ahead and I'll change that out. While I've got it in my hand, we might as well just test it just to confirm that diagnosis. So this capacitor should be 100 nanofarads, and it's actually reading 150. Now that isn't totally awful for one of these old waxy capacitors, because the tolerance was pretty poor anyway. So certainly the capacitance value isn't showing as being too awful. But what I think we'll find is when we actually put it on the insulation resistance tester, I think we'll probably find that it's almost certainly gone low resistance, and that's why it's been getting hot. I think this potentially has quite a bit of voltage across it, this capacitor, and it is rated for 400 volts. So we'll start off at 200 volts. And you can actually see that it's measuring 300k, which is actually pretty much the lowest reading that this meter will actually go. It tends not to go much lower than that. So effectively it's a short circuit at 200 volts. So I went ahead and I disconnected our capacitor, and I replaced it with a modern one. Now in the process I did actually also notice that some of the contact fingers on the switch were also not in the best order. One of the contact fingers was a little bit loose, and it looks like it had actually been loose for some time, maybe since it was originally manufactured. So I had to be very, very careful when I actually soldered the new capacitor in. not to actually break off this contact finger off the selector switch, because they are very, very fragile, and if they do come off, you're in a world of pain trying to put them back together again. So you're going to join me back there where I've put the capacitor in, and we're going to do a little bit more testing. Well, I'm not sure how much you're going to see on camera, but I'm going to join the leg coming out of our capacitor to our wire. What I've done is I've actually just wound a little coil spring, and I've pushed both wires through the centre of this coil spring. And I forget what they call that. Somebody was only mentioning this. I used to know what they call them. It's got a really funny name like wickets or widdits or something like that. I forget the name of them. Leave it in the comments because I've got a memory like a sieve. But this is the way that they used to join wires to component leads back in old radios in the 1930s and 40s. It's quite a common method. Okay, so I brought you in for a little bit of a sneaky peek at this connection I've made, and I've got to admit it's not one of my soldering masterpieces, but I was being very cautious not to overheat this contact. Now, it was interesting because I don't know if you'll be able to see that some of these contacts have got this red stuff on that I like to call dragon's blood. Well, the top of this contact here was covered with the manufacturer's dragon's blood, but it was also actually had a blob of solder onto this central rivet. So I actually think that it maybe even when this was manufactured, this contact here was perhaps a little bit dicky, and you know, maybe the guy who was assembling it put the rivet in, he wasn't quite happy with it or saw it was a bit loose, so he decided to try to solder the rivet to the actual contact finger there. So that's a little bit how you're doing, isn't it? So I'm just thinking what we should do about that. Is it worth trying to give this a clean and maybe put a drop of epoxy over it? Because if this finger does come off, we'll be in a whole world of pain. Now, just to let you know, I have actually managed to fix these fingers in the past, and what I've actually done is got a very, very small little bolt, and I've actually put a nut and bolt through these in place of the rivet and tightened it up. I actually did that on an oscilloscope that I repaired a couple of years ago. That's how I managed to fix some of these contact fingers that had come off, but it's never very easy to do. And now I've moved the camera, you can also see how I've actually gone ahead and I've actually joined this wire to the bottom of this capacitor leg, just using our little wire coil there. Okay, well, I'm guessing it's time for us to go ahead and reassemble our reference scrolls here. I've actually gone ahead and I've actually tried winding them a little bit backwards and forwards a little bit. I was actually taking some advice from Simon Spears, that he was telling me that I think he has one of these, and when you actually roll them they get tightened up to one end, and he's absolutely right, they do get tightened up, and he was talking about it's possible to actually release the pressure on the scrolls by disengaging this little gear mechanism. But taking a closer look at it, I'm pretty sure it wouldn't actually be possible to disengage these scrolls because this bracket is all spot welded together, so I'm afraid we can't really get at it. Now, I'm almost certain to get this a wrong way up. Oh, well, actually maybe not. It looks as though it can only go one way around. I was wondering whether or not to put any lube on these, and because I don't want it to end up staining the paper. Just taking a closer look, it does look as though the original ones had a little bit of lube on the end, so let's go ahead and do that. Now, I did actually have a look through the operating manual for this, or I had a look at online on some information. Now, as it turns out, you could actually buy different reference scrolls for these, so you can actually replace them as more valves got brought out or it got modernised. You can actually change these, and I'm guessing maybe different industries had different scrolls. Maybe if you were into TVs you had a different set of reference information than when you were into valve radios. I'm not exactly sure, but it was certainly possible to do it. Oh, and it looks like one end of our reference scale must have broken off at some point in the past, because I certainly didn't do that. So again, just some more evidence that we're not the first people to have been inside this valve tester. Somebody's obviously had these scrolls off at some point in the past. I think the trick to this will be actually trying to get the scale strip lined up. There's actually like a mark along the that plastic sheet that goes on the front of here, which, I don't know, it lines up kind of a scale for this reference material. I think the trick will be to actually line up that scale, make sure it's straight, especially given the scale's broken off at one end. We'll have to see how we go. Okay, I guess the charm is let's turn it over and see if it is lined up. Yeah, it's lined up good enough, I think, isn't it? It might not be perfect, but I think it's fairly well lined up. Okay, that seems to be moving much better now actually. It seems to have responded to that little bit of lubrication. Still quite difficult to get it to go all the way to the end. I think what happens is because of the years of being stretched on these rollers, the paper rolls become slightly uneven in length, and well, it doesn't seem to quite take it up on one spool to another, so always they get very tight at the end, so that it goes all the way one way. And looking at it, I think maybe it's very slightly twisted, the roll, but there's nothing we can do about it, I don't think. Okay, I think we're better than we were. Well, as you can see, I've actually gone ahead and I've reassembled the valve tester control panel into the cabinet. We've got it switched on, we've got our valve installed, and I've been letting this thing just warm up for a couple of minutes because this valve tester does have a couple of rectifier valves into it. So before you actually do any calibration on a valve tester, you've got to make sure it's warmed up to its proper operating temperature. And also you need to actually allow the valve that you're going to be testing to warm up as well, or you won't get a correct reading. Now the fault with this tester is that we couldn't actually adjust the line voltage because a valve tester, again, it needs to have the right voltage levels within the unit for it to test a valve properly. Because the mains incoming varies from place to place, mains voltage will fluctuate depending on where your house is located, and also different times of the day because the electrical load changes on the electrical grid. So what I'm going to do first before we test a valve is we've actually got to just calibrate the valve tester itself. So to do that, and this is our problem, when I pressed line test previously, this needle here didn't move at all, it was just staying at the bottom. Now when I press it, you can actually see it's going up. So what I'm going to do is I'm going to hold down the line test button, and I've got to do the line adjustment until this pointer lines up here where it says line test. Okay, I think I've got that lined up now. Now I've actually missed out an important step. What I should have done is, I should have also, when I did that, had this short detection switch set to the first position. Now I was going to give a couple of warnings really. I said earlier, before you actually use a valve tester, you've got to make sure that you have all these valve selector switches set correctly. I've gone ahead and I've checked these a couple of times. So what these selector switches do, they arrange to have the various electrodes on the valve connected to the right part of the circuit within the valve tester. So you can see that this describes what the two filament electrodes are on the valve, and then you've got various pins here which are things like the grid, the plate, the screen, the anode and the cathode and the suppressor grid. Those pin arrangements are going to change from one valve to another just depending on what type of valve it is, and also the style of valve. You can see we've got different styles of valve bases here, so you're going to have to adjust these for every valve that you test. Now it is important you get those right. The other thing you need to do is you need to know that the valve doesn't have any short circuits on it before you actually do the test for mutual conductance, because again, if the valve is really badly damaged, internally short circuit, it could actually damage this meter movement, and that's something that I was going to give you a warning about. So I said that valve testers can be easily damaged. Well, really what you're talking about is these meter movements can be very easily damaged, and sometimes it just happens even when they're in normal service because there's actually a fault with the valve that you're testing. But if somebody hasn't used a valve tester properly or has been really unlucky and had a damaged valve, what can happen is this meter movement can wang over, it can damage the meter movement, it can burn it out, it can go open circuit. And a lot of these meter movements, these are actually manufactured specially for valve testers, so it's very unlikely that you will be able to get a replacement meter if you could get one, it probably wouldn't be calibrated correctly. So really it's a bit of a problem. So if you're thinking of buying a valve tester, probably a good idea to check out that this meter does move before you actually purchase it. There's an awful lot of valve testers that go onto eBay and they'll say like spares or repairs, and I've got to admit I suspect that a lot of the people that are selling them, they know that these meters are burnt out and it's a real problem. So, you know, buyer beware. Make sure that you've asked the seller if he can't test the meter for you or it's in an unknown condition. Unless it's very cheap, I wouldn't even take the risk on it because it's a very difficult thing to repair. Okay, that's my bit of a lecture on valve testers. So of course what I should have done is, first of all, when I set the valve tester up, I should have had this switch here set to the short position. So what this will do is, this is going to test all of those electrodes on the valve, and it's going to look for short circuits between them. Now if there is a short circuit, this light that says short on it will light up. So if I flick the switch, okay, that's okay. We've got a flash there, that's normal. Sometimes when you change the switch from one position to another it will flash. So having done this short circuit test here, we've put the switch into the tube test position, and now all we actually have to do is we have to just press this P4 button, and hopefully the needle is going to move up here and it's going to go into the good section. Now according to the scale here, it actually should come up with a reading of 7,500. I've never actually got that to work on any of my valve testers. They very rarely seem to give the GM value which they state in these catalogues. Usually they exceed it. Now I've got to admit, I actually haven't bothered to internally calibrate this valve tester. They do need calibrating from time to time, and I probably should have calibrated this one when I actually got it from America, because I don't know if it would make a difference or not, but obviously America's on 60 Hz, now it's running on 50 with a slightly different transformer. So it could actually be that some of the calibration resistors inside need adjusting. So we'll press the button and it is actually coming up just a little bit higher than I would expect, but it is going into the good. And also I've just noticed that this fuse lamp is just glowing very slightly. Well, I can't really tell you if that's normal or not actually, because I haven't tested enough valves with this Hickok tester to know. You know, a lot of things in life, it's all about experience, isn't it? I think I've only used this valve tester literally 2 or 3 times, and this is one of the reasons why I don't really like using valve testers, because they can give you very, very misleading readings and you can end up chasing your tail. You can actually do a valve test on a tester like this. It will tell you the valve's good, and you'll put it in a radio and the valve doesn't work, or quite often the opposite way around, that this will tell you that a valve is bad but the valve will actually work fine in the radio. Now a valve tester doesn't always replicate the same conditions in a radio receiver as those test conditions, so you can get variations. So again, that's one of the reasons why I said earlier that although I have valve testers, I very, very rarely use them because I find it very difficult to interpret the results that they're giving me. So as I said, this fuse lamp does seem to be glowing slightly. Is that normal for this valve tester? I really don't know. Maybe it is, maybe it isn't. Maybe you can leave it in the comments if you've got one of these Hickok 533 testers and you're a bit more experienced than me. Now regarding the calibration, it is actually possible to calibrate these. There is some instructions online for how to do it, and if I had a bit more time this week I did actually plan on doing a calibration, but I think that will have to wait till next time because I'm quite anxious to actually get back onto my television. It's just that I did have some valves I needed to check for somebody, so we had to do this today. So we've done everything we can. This is going to go back under the stairs for another 10 years until maybe we need it again, and that's going to allow me to get back onto our television repair. But I think for today that'll do. So until next time, as always, thanks very much for watching, and I hope to see you again very soon. Until then, bye bye for now.